Next type of induction relay is nothing but the watt-hour meter or double winding structure. So here we are using two magnets. First is called as the upper magnet, which is of E-type shape, and second is called as the lower magnet, having the U-type or C-type of shape. Then on the spindle we mounted the aluminum disc along with which is pivoted along with the moving contact and the two contacts to the trip circuit. As the name itself suggests, it is having double winding. That's why one winding is placed on the central limb of the E-type upper magnet, which is called as the primary winding, whereas the secondary winding or the second winding is divided into three sections, and one section of it is placed on the central limb of the upper magnet, whereas the remaining two sections are which are having the equal number of turns are wounded or placed on the two limbs of the U-type or the C-type core of the lower magnet. As well as this second coil, which is called as the secondary winding, is short circuited on itself like this. Now whenever we will pass the current I1 through the primary winding, then it will produce or set up the flux Phi1. These Phi1 fluxes flows through the core of the upper magnet and then to the aluminum disc. At the same time, as one section of the secondary winding is placed on the same limb, that's why that fluxes will interact with this section and induces us an EMF in that second coil. But as the secondary coil is short circuited on itself, that's why the magnitude of the induced EMF is very less, but a huge amount of current starts to flow through that secondary coil, and that current, that is the I2, which is flowing through the total coil, sets up its own magnetic field. Due to that magnetic field, the second flux Phi2 is set up in the low magnet and it starts to flow through the lower magnet and then to the aluminum disc. So in this manner, two different fluxes are produced by the two magnets. Upper magnet produces the Phi1 number of fluxes, whereas the lower magnet produces Phi2 number of fluxes, and both of the fluxes are displaced from each other by an angle of alpha. And as we earlier discussed, the force which is directly proportional to the magnitudes of individual fluxes and the sign of the angle between that two fluxes. That's why the force exerted or force produced by the aluminum disc F is directly proportional to Phi1 into Phi2 into sine of the alpha, that is nothing but the angle between the Phi1 and Phi2. At the normal condition, the disc will not be rotated, but whenever the abnormal condition occurs, then the disc will rotate, and by rotating the disc, this moving contact will bridge these two contacts of the trip circuit, and that's why the circuit of the trip coil will be completed, which will give the signal to the circuit breaker coil, and circuit breaker will disconnect that faulty section from the healthy section to protect the total power system.